guys, we are still dealing with multiplying or dividing with powers of 10. This lesson specifically deals with multiplying powers of 10. And that's also, anytime you see it say a multiple of 10 or a power of 10, we're going to be talking about the same thing. It's going to be things that are ending in 0. Okay? And it asks us just to find the value of each mentally. And we've talked several times about a quick math tip. If I had 50 times 6, quick math says I can multiply my two whole number parts. So 6 times 5 is 30. And how many zeros did I have remaining that I had not used? I had 1. So and then I think, does that answer make sense? Is that reasonable? Well, we know 50 times 5 is 250, so then if we had 50 one more time, we had it 6 times instead of 5. If we added 50 to 250, then we would get 300. So yeah, that answer is reasonable. That makes sense. Okay, now if we just determined that 50 times 6 is 300, but now we are doing it 60 times instead of 6 times. So are we doing it another 10 times? Yeah, okay, so let's see. If this was 300 and then we did 50 another 10 times, I would have what? 10 times 3 is 30, and then how many remaining zeros that were unused? I would have 2. And that makes sense. 50 times 60, if we just use quick math on that, we could look at it as we take this one and then we did it 10 times what we did use. Instead of 6, we did 60, which is 10 times more. Or we could use quick math. Take the whole number part. 6 times 5 is 30. And then how many remaining zeros had not been used? 2. We still end up with the same answer. We still end up with 3,000. There's just multiple ways that we can get there. Okay, let me keep it up some. Okay, we determined that 50 times 60 was 3,000. So now, instead of doing it 60 times, I'm multiplying it 650 times 600. And that's 10 times more than I did before. So, let's see, 3,000, 10 more times, because we're doing it 600 instead of 60, so that's 10 more times that I have multiplied times 50. Multiply my whole number parts. 1 times 3 is 3. Or 10 times 3 is 30. Used that 0 already, and I have 1, 2, 3 remaining zeros. So I would get 30,000. Or I could do quick math, quick estimate math. 600, remember when we're multiplying, we always put the largest number on top. Doesn't change the answer. Okay, so we would have 600 times 50. Quick math, 5 times 6 is 30. And remember I said 5 times 6, not 50 times 6. Just 5 times 6. So I haven't used this 0 yet, have I? 5 times 6 is 30. I still haven't used this 0 because I didn't multiply 50 times 6. I haven't used this 0 or this 0. Did I end up with the same answer? Yeah, I end up with 30,000 whether I take my previous number and think that I did that. I multiplied 50 10 more times and got 30,000. And I multiplied on this side 10 times 3 to get the 30. So I had already used that 0 when I multiplied the 10 times 30. So then I had 1, 2, 3 zeros that I hadn't used yet. And then on quick estimate math on this side, we get the same answer. 5 times 6, because that's a smaller math step for me to do than 50 times 6. 5 times 6 is 30, and at that I hadn't used that 0 yet because I didn't multiply 50 times 6, just 5 times 6. So then I would have that 0, and that 0 all to bring down. Either way, we end up with 30,000. So let's move that up, and then we'll put that answer out there. We know that that's 30,000, okay? And, oh, then it does my 0 on the other number. It put it on the 50 instead of the 6 like it had started. It started with 6 and then went to 60, which was 10 times more, and then went to 600, which was 10 times more. But then it changed the other number. But is this one still just 10 times more? It's still just 10 times more, isn't it? So if I start to look at the pattern, each time we've added another 0. Because each time we started with this, and then it went to this, and then it went to what we have up top, 50 times 600. And every time we added a 0 into our factors, what happened to our product? Each time, I had 2 zeros the first time, and then they added another 0 to my factor, so I have another 0 here. And then the 3,000. They added another 0 to one of my factors, so look at my pattern. Each time it's adding another 0. So if now they've added another 0, then I should be able to quickly estimate if they added another 0 here, what's going to happen to the 30,000? It's going up by another multiple of 10. So it would be 300,000. And it never hurts to quickly check it. If I stacked, I would have 600 times 500. If I just multiplied the number in the hundreds place, I would have 5 times 6 is 30. I haven't used this 0 yet. I hadn't used this one yet. I hadn't used this place value yet, or this place value yet. Did I end up with the same answer? Yeah. So let's just start to see that pattern, how it works when you're increasing by multiples of 10. If you increase your place value here by a multiple of 10, by adding a 0, then you would also add a 0 to the next product. Remember, product is just the answer to a multiplication question. So let me throw this one out there. If they gave you 6,000 times 500, did we just add another 0 or another multiple of 10 to our factors? Yeah. So if logic serves me right, then I would have this number plus one more 0 because they added a power of 10 here. So I would add a power of 10 here. And again, it never hurts to check yourself. 6,000 times 500. 5 times 6 is 30. I hadn't used this one. I hadn't used this one, nor the ones place, the tens place, or the hundreds place. And did I get the same answer as just using my general estimation logic? Yeah, we still got 3 million. So if one of the factors is increasing by 10 times, a multiple of 10, then your product will simply increase by that same place value. So you would have one more zero on the end. Okay, this one's asking us to do just reasonable estimates. We're still estimating. Which estimate for the product of 18 times 149 is the most reasonable? Now, it's a lot easier to look at 149. If I estimated and rounded 149, would I have 150? Yeah, I'd have 150 if I estimated that. And if I rounded this to estimate 18, would I have 20? That's the closest number to round to, right? Okay, and now I know, using quick math, if I have powers of 10, if I'm working with powers of 10 or multiples of 10, I can multiply the whole number of parts. 2 times 15, I know that. That's a quick math. That's 30. 15 2 times, if you also need to do it this way, that's fine. 15 2 times gives us 30. And then we haven't used this place value yet or this place value yet. So 150 times 20 is 3,000. So our most reasonable answer would be C. Do you think the actual product, because we used 20 and 150, and we got is that correct? Count your zeros. Is that correct? No, we got too many zeros up there, don't we? Okay. 15 times 2 is 30, and then our multiples of 10, 1, 2. Okay, so our estimated product was 3,000. Our actual numbers were 18 and 149. And it asked, do you think the actual product would be more or less? Well, I think it would be less because this number was less than what we rounded to. It's 18 instead of 20. And this one is also less. I have 149 instead of 150. So I think that it would definitely be less if I'm looking for my actual. Okay. Let's look on flip on over to page 114. 114. Okay, on these we're still multiplying. Now, it tells us to evaluate each expression and explain your answer. Well, if I wanted to quick math this, I could say, if I was estimating, I could keep 18 here, but 9, is 9 just almost 10? Yeah, and that's easier to quickly do in my head with my mental math. 18 times 10 would be 180, but I didn't have 18 10 times, did I? I had 18 9 times. So if I just use mental math for a minute, I had one less set of 18. So if I subtract that 18 from the 180, I would have to borrow here. Okay. 10 minus 8 is 2. 7 minus 1 is 6. And 1 minus 0 is 1. So I see that 18 times 9 is actually 162 because I can quickly do a multiple of 10. 18 times 10 gives me 180, and I can do that quick. And then I think to myself, okay, that was 18 10 times, but I only had 18 9 times. So I just take away one of the 18s. Okay, on this one, it works the same way. If I round my numbers, they're quicker to find. So if I round my numbers, this would be 18 times 50. Now that's easier to work with because I can come over here, 18 times 50. I can do my quick math. 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9. And then I had one place value of multiple of 10 that I hadn't used yet. So if this is 900, I can do quick math to find that one. And then let me think, let me reason. Let's see. Okay, the actual problem was 1849 times. But to be able to do it quicker, I used 1850 times. So I had 18 one less time, right? So if I take away that 18, if I borrow here, if I borrow all the way across, I would have 10 minus 8 is 2. 9 minus 1 is 8. And 8 minus nothing is 8. So if I do it quick math by estimating and using multiples of 10, then I can just take away that 118 that I didn't have. I didn't have 1850 times. I had 1849 times. So I just took away one of the 18s from where I could do it quick math with multiples of 10. Okay, and next one. Same process. Okay, if we said, let's get this one together. We said this was, when we used it times 50, 18 times 50. 18 times 50. We did our quick math. 5 times 8 was 40. 5 times 1 was 5. Plus 4 is 9. And then we had the one that we didn't use yet. Okay. So this was 900. And then we took 18 away from it and got 882. Okay, so now from the last unit that we did, we determined that if you're adding another place value, we can add on to that. So let's think about that for a minute. I already know that 18 times 50 is 900. And I already know that that would be one less set of 18, so I could subtract that out. Now, if I had 149 times, how many times larger is that than 49? How much larger than 49 is 149? Okay, we could do this one two different ways. We can look at this, and if we were looking looking at it as 18 times 150. Think about that, 18 times 150. That 8's not wanting to work right down here on my board. Getting really close to the bottom. So let me move it up just a little bit, and I'm gonna rewrite that problem. The original problem was 18 times 49, and we estimated up to 50 so that we could use quick math, and we took one of the 18s away. Okay, so now, if we look at this as, use red again, if we look at this as 18 times 150,